Hello folks. So today we will build a maze generator in JavaScript. So I have a maze here and clicking on the generate maze button, lots of very interesting maze shapes are generating. Now we can also use the same concept in Godot and we will also see that in a future video. So today let's open our VS Code and let's see how we can build this. Now in my VS Code, I have an empty index.html file. So I will quickly generate the boilerplate. I will rename the title to maze generator. In my body, I will need a canvas, a button called generate maze, and I also need to attach my script.js file, which is empty right now. So let me attach this file, and I will also give some minimal styles. So for our canvas, I will give the style as one border, one px solid flag, and for the body, I will give a margin of 20 pixels. Now, if I open with live server, let's see what we get. So we have a canvas and we have a maze. The size is not proper, but this is something we will take care of in our JavaScript. So in my script.js, I will first define the canvas equals to document.querySelector canvas, and then I have to create the context. So canvas.get context 2D. This is essential for our drawings. Now we also have to take care of the generate btn. So the generate btn, I will select document dot get element by id. Let me also give an id here. So I will give the id as generate btn, and let me select it here, generate btn. And now for our maze, we need to define some dimensions. So let's assume our maze will have 25 rows and 25 columns, and the size of each row and column, let's call it cell size, will be 20. Hence, our canvas width and height becomes 500. Basically, rows times the cell size, we can directly write 500. Otherwise, if we change these things, this will be dynamically generated. I think that is also fine. So we'll define the width and height in this way. So the height will be rows and the width will be columns. Now we also need to define few more things. So for example, we have our path and we have our wall. So let's define some colors for our path and our wall. So I will give the wall color as, let's say, black. And when it comes to our path color, let me give the color as white. If we go back to our browser, this is how it looks like, which is fine. Let me also open the console for debugging purposes. So now let's try to understand what we need to do now. So we have to generate our maze. So our maze is basically an array of values, and we also need to draw our maze. So we will need two functions like this, generate maze. We need to call that, and then we need to draw our maze also. And whenever we are clicking the generate btn, again the same two functions should be called. So generate btn dot add event listener. I will do a click, and if I click, I want the same two functions once again. So let me copy and paste here. Now this will throw an error because we don't have these functions defined. So now let's try to define this function. So we'll define the function draw maze, and this is empty for now, but this will be filled soon, and also a generate maze. Now inside our generate maze, what do we need to do? We need to assign some values for our walls and our path, and accordingly we have to draw it in our draw maze. And before doing any of that, we have to initialize our maze. So our maze will be a 2D array. We can assume that. So we can create a 2D array like this. So first of all, it will be an array of rows, and we will fill it with some columns. So dot map for every row, I want to fill it like array of calls, and I will fill it, let's say, with a value of 1. Now, if I log my maze, it will be a 2D array, and all the values will be 1. So as we can see, everything is 1. So everything once means, let's assume everything is a wall. So the total maze is black. Now, this is definitely not something that we want. We want ones and zeros carved out in a particular order so that it looks like a maze. So inside our draw maze function, um, we can start by drawing it, and then we will see how we can basically create a maze. So whatever we have, let's try to draw it. So this draw maze will be called again and again with some values. So we need to clear it first, and we have to clear the entire canvas. So dot canvas width and canvas height. Then, because it's a 2D maze, so for every row equals to 0, and row should be less than rows, and row plus plus, and then for every column equals to 0, call should be less than calls, and call plus plus. I think there is some sort of an error here because this should be a semicolon. And now let's give a ctx.fill style. This fill style should be depending on it is a wall or a path. So if it is a wall, it will be black. Otherwise, it will be white. I mean, either the white color or the black color. I mean, or the path color. Uh, Whatever colors we have defined. So here we need to check if the maze value of the row call. If this is equals to 1, then this is a wall. So then the color will be a wall color. Otherwise, it will be a path color. And then accordingly, we have to draw a rectangle. So ctx.fill rect. And here, the x and y value will be whatever coordinates we have. That is basically just a number, but that need to be multiplied with our cell size. So call times cell size, comma row times cell size, and the width and height will be our cell size, of course. That's all. And so this is our draw maze in short. So now if we see, everything will be black because the whole maze is a wall. What do we need to do now? So if we go back, and also to show you, if I just make it with 0, everything will be white. So let's just keep it 1. And let's try to understand how do we need to generate the maze. So drawing a maze is whatever we have, it will simply draw here. But generating the maze is adjusting this array. So how can we adjust this array effectively is the main part that we need to take care of. So we will first assume that we are starting to draw our maze from the index 1, 1. So we'll define the start row as 1 and the start call also as 1. And hence the maze start row start call, wherever we are starting, that must be a path. So the start row start call, this index should be 0. And now if you take a look at our maze, we can see one white box inside a big black box. And that is because one value has become 0. And this is where we are starting, and we need to carve out our maze. So how to carve? So whenever we have one white box, we need to see that what other adjacent boxes can be white. And we need to check for every white box because we cannot simply randomly pick out boxes. That will look weird. So whenever we have a white box, that is whenever we have a path, we need to see if adjacent paths can be there or not. And accordingly, we will carve out the maze. So this is like a huge rock, and one miner is basically digging the rock. You can assume it like this. And what we need to do is we need to see what adjacent paths are available. So for that, we will just write another function, and let me name the function as carve passage. And here we need to pass our start row and our start call. Now let me create a function called carve passage. And here we will have our row and column. Let's use a shorthand RC. Now we will check uh, 4 directions: up, down, left, and right. So I will create an array of directions. So this will again be a 2D array, and there will be 4 directions: -2, 0, then 0, 2, then 2, 0, and lastly 0, -2. Now, if you think for a minute, this is basically our left, this is basically our down, this is our right, and this is our up. Now, why -2? Why 2 cells? Why not 1 cell? And we will see that why we are taking 2 cells and not 1 cell. Taking 1 cell will give us some weird results, and we don't want that. So what we are trying to do basically is we are checking 2 cells to the in every direction, and we are checking like what is that cell? That is a wall, or that is a path, or like what is it with that cell? And accordingly, we will create our paths. Now we also want to shuffle our directions for some randomness. So what I will do is direction.sort, and we will use the random sort. So math.random will check if this number is negative or positive, and accordingly we will sort our directions. If I now simply do a console log, you will see that the order has shuffled. So let me go back to console, and if I refresh, I mean, you can understand that there will be a different order every time, and that is exactly what we want. And now we need to check, check these paths and accordingly draw our maze. So I will create a for loop and we'll destructure our directions. So let's take the row as dr for direction row and dc for direction column of direction. And here we will take a new row as our r plus dr, and we will take a new col as c plus dc. So we will have four iterations of direction, and hence we will have 4 such pairs of new rows and new columns. If I simply do a log of new row and a new col, you will see what we get. So we get 4 values in 4 directions. So this is 1, 1. So we are getting a 1, 3. Now this 3 is not valid since, no, 3 is valid because it's here, this col. I mean this cell. This is not valid because -1 is like above the maze, so we have to check these conditions. But we will basically get 4 values. So instead of a 1 1, if I let's say start at 10 10, then all 4 directions will be valid. But yeah, that is something that we will take care of. We will call the cart passage repeatedly, and it will take care of the whole maze. So now I will check if new row is greater than 0 and new row is less than rows minus 1, and new col is again greater than 0 and new col is less than cols minus 1. And one last very important thing, that is maze of new row and new col, this is equals to 1. So we can only carve if we already have a wall. So the last condition is very, very important. And then we need to carve our walls. So we need to carve 2 walls. So this is the second index we are checking. So we need to carve a wall in the first index as well as the second index. So first things first, maze, new row, and new col. This should be 0. This is the second index. And how we will get the first index, that is maze r plus dr by 2 and r and c plus dc by 2. This should also be 0. And then we have to recursively call the cart passage. And we will pass a new r, new row, and new col. And we will have our amazing maze generator. If we click on the generate maze, nothing seems to work. And this is because we are actually missing something simple yet very important in our generate maze function. So what we need to do here is we will first copy our for loop from our draw maze. So we have to look through all our rows and columns. So let's paste this here. Let's also take care of our brackets. And here, what we have to do is whenever we are generating our maze, we need to fill the values of our maze once again. So we have initialized our maze here with all values as 1. And once we are generating the maze values are changed. But when we are clicking on the generate maze, what it is trying to do is it is trying to create another maze from the 1 position. But it can only create maze like new mazes when every index is a wall. So we have to set that once again. So whenever we are generating the maze, so what we will simply do is maze row call equals to 1. And now everything will work perfectly fine. So we are generating lots of amazing mazes. Now, let's address some concerns that you may be having. And one of them could be why we are checking the second cell and not the immediate cell. So we have taken 2. What if we would have taken 1? That is the immediate next cell. So our sort will work fine. Now here, instead of adding by 2, it will add or subtract by 1. And these checks are perfectly fine. But here we don't need to draw like 2 paths. We can only draw 1 path. And we can simply draw the new row, new column. The second one will not be required. Now, if we do this, we will see some weird results, and the whole maze is a path. And this is the problem that we are facing when we are checking the immediate next. Now, there is a way to address this, and that is here. But let me tell you that this is not a good approach. I mean, you will not be able to create amazing mazes with this. But still, let me just show you. We will check if math.random is greater than, let's say, 0.95. Only then we will do 0, otherwise we will do 1. So we are not basically carving out all paths. And now if we check, it is doing lots of calculations. It is computationally very heavy. So let me try to make it easy. We'll only give it 75. It is still difficult. Let's give 0.5. And as you can see, even after giving a 0.5, it is giving us some walls and lot of path. So this is definitely not something that we want. And this is the reason why we avoid these things. We take the second path. Now you may wonder we could take 3 also or 4 also. So let's take a 4 instead of 1. And here I hope you guessed it correctly. We will need to carve 2 more paths. So let me just take 2 more, and not these actually. Let me just copy these things. So there will be a divide by 4, and then there will be a divide by 4 times 3, and same goes here because we are checking the fourth cell. So again divide by 4. And now if we see, we have some maze, but the walls are much thicker. And there are some extra walls at the side, and this is because it is checking the every fourth one, and there is a border issue, that's why. So one way to resolve this, here we can simply make it 27, I believe, instead of a 25. And now I think this is a better maze. We can click on the generate maze. It will create new mazes. So if you want thicker walls, you can definitely use this. I think 2 would be much better. Um, let's check with 3 ones. So here we will need 3. So 1 is the third one we will need. Another one is the 3 times 2, I believe. So let's see what we get. And yes, we have once again, I think this maze looks much better even than the 2. And by clicking on this, we can again generate lots of mazes. So that's it for this, folks. And we will also very soon do this in Godot. But before that, we will see some few more Pathfinder and maze generation in JavaScript, different kinds of mazes and how to find paths. Like if there can be an apple at this corner and the player is coming from here, so how can the player reach the apple? Something like that. And yeah, so if you have learned something new in this video, make sure to like, share, and subscribe so that I can grow the channel fast. And I will see you very soon in another very interesting video.